In this video, we will learn to graph linear functions in slope-intercept form. Please use the notes provided to follow along. Before we get started, let's review graphing lines so far. Yesterday, we graphed lines with given information. If we know a point that's on the line and the slope of the line, we should be able to graph it. So remember, we'll start by plotting the point. So this point, -3, is to the left and down 4. That's one of the points on our line. And then we also know the slope of the line is 3. Remember, we can make that a fraction. So 3/1 represents the rise and the run. So from this point on the line, we can go up 3/1 and put another point. Up 3 from there, over 1, and up 3 from there, over 1. So I was able to fit 4 points on this graph and then connect those 4 points to graph our line. So having a point on the line and the slope was enough information to graph it. Last chapter, we also graphed lines by making tables. So take a second to try filling out this table. I'm giving you 4 x values to plug in for x. You find the y values, plot them, and remember they should all line up to make your line. Right, plugging in -2 should have given you 1. Plugging in 0 gave you 2. Plugging in 2 gave you 3. And if you noticed a pattern, plugging in 4 gave you 4. So those y's definitely formed a pattern because this is a linear function and your x's were in a pattern. And then you can plot those. So those, remember, represent 4 points on our line. So -2 and up 1, over 0 and up 2, over 2 and up 3, and then over 4, up 4. So if you plotted those 4 points from your table, connect them, you should see your straight line. Now that's how we graphed last chapter. This chapter, we're going to try to find a quicker way to graph this equation and hopefully not have to use the table. So look at this equation that we graphed and the line that you just graphed and notice the relationship between the two. So the two numbers from the equation pop up on our line. So the number 2 in our equation represents the 2. It's a point on our line. Specifically, it's the y-intercept point of our line. And the 1/2 in our equation represents the slope of the equation. So from point to point, you can go up 1 over 2, rise and run, up 1 over 2. So the slope of this line is 1/2, and that number appeared in our equation. So that's how we're going to graph today without having to make the table. We'll save ourselves a lot of time by graphing from what's called slope-intercept form. So slope-intercept form is going to allow us to graph from an equation without having to make the table. Slope-intercept form is this: y equals mx plus b. So rather than having to plug in some x's and y's and making a table, we should be able to look at this equation and get the information we need. Remember, we just need a point on the graph. Well, this b number is a point on our graph. Specifically, it's the y-intercept point of our graph, or where the graph crosses the y-axis. And the m number is our slope. So having a point on the graph and the slope of the line will allow us to graph our line. So we'll use that number to rise and run. So not rum, but run. Okay. So starting from our y-intercept, sometimes I tell students B stands for begin. So we'll begin with that number or that point on the y-intercept, and then we'll move using our slope to rise and to run. So let me show you some examples. All right, let's start with an equation of a line in slope-intercept forms. So let's try y equals 2/3 x minus 4. Now remember, slope-intercept form was y equals mx plus b. So since this equation had a minus on the end, that -4 is going to be our b, or our y-intercept, and then 2/3 is our slope. So that will tell us how much to rise and to run. So first we'll have to start with a point on the graph. So we'll start with -4 as the point on our y-axis, our y-intercept. From that point, we can rise and run by going up 2 and over 3. That's actually all the points that will fit on this graph, but that's enough because with 2 points, you can make a line. If we had been able to fit more graphs, we could keep, or more points, sorry, we could keep rising and running. But this alone allows us to connect those 2 points and make our line. No table necessary. All right, example 2, let's try to graph y equals 3 over 2x plus 1. So the 1 represents our b, or our y-intercept, and the 3 over 2 represents our slope. So we will begin with b by putting a point at 1 on the y-axis, and then use our rise and our run to count from there. So from that point, we can go up 3 over 2. Notice that we could fit other points if we had gone the other direction. So remember, from this original point, instead of going up and to the right, we also could have gone down 3 and to the left. That'll also give us a point on the line, and from there we could have counted down 3 and then left 2. So 2 negatives also make a positive, so that allows us to get 4 points that fit on our line. So we want to try to practice graphing these lines as straight as possible by getting as many points as possible to fit. What if we had y equals 3/4 x? And it stops there. So in this case, there's nothing added to the end. In essence, you could think of it as a +0 on the end. So your b value is just 0. And then your slope is 3/4. So try graphing that one. You would start at the origin for 0 and then count your rise and your run. Up 3 and over 4. But how else could you have also moved? If not up and to the right from the origin, you could have moved down 3 and to the left, because again, 2 negatives make a positive. So going down is negative and to the left is negative, and that's still going to give us a positive line when we graph it. So those are both positive lines because the slopes are positive, they're going uphill. So let's do some more practice with some negative slopes. So what if our slope's negative? So we could have y equals -2/3 x plus 2. So the +2 tells us that the b value is +2, but our slope this time is negative. So let's start at +2. And then to get a negative slope, remember we have a couple options. We could think of it as -2, so down 2, +3, so down and to the right. Or you could have also thought of it as 2 being positive and the 3 being negative. All right, so our other option could have been to go up 2, but then to the left 3. So we need one of those movements to be negative so that when we connect, we get a negative line. Remember, lines that go downhill represent a negative slope. So here's one for you to try, another negative. How about y equals -1/5 x minus 3. So try graphing that one. The b value is -3. And then again, with a negative slope, you have options. You could have made the 1 negative, so go down 1, and then to the right 5 would be way over here. Or your other option would be to go up 1, so that's positive, and then to the left, make the 5 negative. So both of those were your options to get a nice negative line. All right. Hopefully you're getting the grasp. Let's try a couple more just to cover anything and everything about graphing from slope-intercept form. What if we have y equals 2x minus 4? Well, again, the -4 on the end will tell us to start at -4 on the y-axis. In this case, the slope is just 2. Remember when the slope was a whole number, however, this is the one time we like fractions, so we really want to think of that as a fraction still. So 2/1 will tell us how to rise and run. So from -4, we'll go up 2 and over 1, and we'll keep repeating that to get lots of points on this line. So up 2 and over 1 again, up 2 over 1, up 2 over 1, and there's our line with a positive slope of 2. All right, what if we had y equals -3x minus 1? -1 is our y-intercept. Our slope is -3. Again, that whole number we could turn into a fraction by putting it over 1. So we have some options. We could go down 3 and to the right. Our other option would be to go up 3 and to the left, up 3 and to the left. So we should be able to fit 4 points on this graph with our negatively sloped line. All right, these are our final 2 examples, so take a second to write them down, and since they're our last examples, why don't you pause the video and try them without me. All right, let's compare how you did in number 8. The y-intercept was 4, the slope was 3, which we could think of as up 3 over 1. Now, perhaps you ran into a little bit of a problem, because if you start at 4 and then you try to go up 3, that would take us off the graph, or we would run out of room. So here we have to think about, okay, do we have any other options? Sure, we could also get a positive by taking 2 negatives. So instead of going up and to the right, we could have gone down 3 and to the left, down 3 and to the left, down 3 and to the left. So that's still going to give us, notice when I connect these, this line is still positive, but we didn't have room to go up 3 and over 1, so we just had to think about taking a new route, and we went down 3 and to the left 1, because again, 2 negative movements can still turn out to give us a positive line. The same thing potentially happened over here. All right, so we started at -4. Our slope was -2, so if you tried to go down 2 over 3, that took us somewhere down here, technically off the graph. So how else could you have moved? You could have also gone up 2, but then to the left 3. And so this would give us a negative line as well. Right? So just some things to think about, but the moral of this story here is that graphing from slope-intercept form is so much quicker than making a table. We can just use the equation and the information given in the equation to find our b value to begin on the y-intercept, and then our m value, our slope, to rise and to run. You're going to now get the opportunity to practice on your own by going to Delta Math and following the normal steps to log in and do the 10 problems there to practice graphing from slope-intercept form.